Hey guys, we got a trouble call for a frost-free freezer door malfunctioning. I've been here before. I've troubleshot this door before. I think it's been about a year or so. It's a large freezer that fork trucks drive in and out of for loading and unloading frozen goods. To get in and out of the freezer, they've got a large door with plastic hanging, a double layer of plastic, and when a fork truck driver approaches, he either pulls a string or there's a little motion detector and it swings those plastic doors open and lets them drive in, and then when they need to exit, they pull a string and the door opens and they drive out. So during normal operation, there's just these plastic dividers there, baffles I guess you'd call them, and in between those baffles hot dry air, not exactly hot, but heated dried air is blown positively to create a buffer between the outside air and the inside freezer air. The air outside is very, very humid, especially here in Hawaii, but anywhere you have a freezer that's the case. And the air inside the freezer is kept very dry so that you don't have frost forming on everything. What happens is, I guess there's one more thing to explain about this door. The blower that blows the air, the heater that dries the air, and the motor that opens and closes those vanes are all on essentially one circuit. There's a step-down transformer for some of the controls. You know, there's smaller fuses for each of those components, but all of those components are at the top of this door, about 15-20 feet off the ground, and they're all dependent on one another. So if the fuse pops for the whole door, or if the controls stop working, the blower will stop running, or if the heater stops going, it will, what do they call that? It gets out of control quick. Basically what happens is, now that there's no dry air in that space, the humid air comes right through the door and goes right up into this whole control compartment. The humid air meets I believe they keep it at 10 degrees Fahrenheit, so below freezing. Might even be in the negative, I'm not certain, but it's very cold freezer air. The humid outside air meets that, condenses onto any surface in there, and then it freezes. So what I'll likely see when I get there, what I've seen in the past, is this control enclosure for the door is inside the freezer area, and it's going to be filthy, for one thing, from all the dust, and it's going to be covered in ice, so frozen solid. There'll be usually a thin layer, depends how bad it is. The inside of the freezer area can be frozen. What they do when this door fails, as soon as they notice, they shut the door. They shut like a sealed mechanical, like a traditional door, to keep the draft from blowing through. But in that period when the door isn't working, that's enough time for frost to form. Then the other fun part with this is, as you turn it back on, the heater warms that space, and the frozen water and dust that's covering all of the electronics begins to melt and conduct electricity. So I've seen trace arcs here jumping from one terminal to another through the dust and ice. Real fine, about the width of a human hair, but blue like a little arc, and enough to, you know, blow fuses and cause havoc. It was getting so frustrating. The last time I came, I swapped out the control fuses with DIN mount circuit breakers. My thinking being, okay, man, we're just going to be burning through fuses here. Fuse, 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 fuse every time there's a door fault, trying to troubleshoot where the problem could be. So we put in those circuit breakers so I could at least just reset and set again. We did have one time where there was some vibration. I forget if it was caused from a bearing or a belt in that blower, and that caused a connection to short against the metal of the enclosure. So there's always like a initial problem that kicks off the failure, either a ground fault, in the case of the wire hitting the door. But as soon as the failure occurs, then there's this cascading failure of, okay, now there's humid air coming in, freezing over everything, and causing little short circuits between the control wiring. So my checks when I get there, after I get suited up in Arctic gear, is going to be just to check supply voltage for starters, make sure the supply voltage is coming up. Then before I even try and energize it, I just want to verify that all the mechanical aspects are good. There's some gears and pulleys. I've seen those fail in the past as well. I had a chain fail. It's basically the door motor just spins a gear that operates a chain that opens and closes those baffles. So voltage checks, mechanical checks, make sure the chains are good, the gears are good, all the arms are good. Then if I'm satisfied with all of that, I can go ahead and re-energize it and try and get the blower working. See if the blower will blow, make sure there's no shorts there or melted wires, make sure the heater's working. Then I can look at making sure the door actuates the way it's supposed to, opens and closes. So yeah, it's convoluted, and it being in the freezer and me being a thin-skinned Hawaii guy, I can't stay in there for too long. After about 15 or 20 minutes at 14 degrees, I gotta come out and take a break, thaw my fingers off, warm up a little bit. Especially most of the work in there I can't do with the large gloves. I think the longest I went was about a half an hour, but yeah, I'm a real sissy when it comes to cold weather, living out here in Hawaii. But we just do what we gotta do and take breaks as we need to, and hopefully we can figure it out. But that's kind of a good guide for troubleshooting, is start with the basics from the furthest out. I'm going to talk to them and see what the initial symptoms were, if there were any, and then check voltages and check mechanical stuff, make sure everything's operational that way, and then just start powering it up and seeing what happens. Yeah, I'll see you there, see what I can do. There's the door, there's the disconnect switch. See all the baffles. Here's the area inside the baffle. See, the air comes out of those and blows straight down, and these baffles swing out. Right now they've got it shut with the main garage door closed. So the next step is to climb up there in a lift, take a look inside those enclosures. They're saying they're getting a whole bunch of shorts and blown fuses, and they don't know what's causing the fuses to blow. They said even these main ones down here, the disconnect were blowing, and ones up top, so probably got a short somewhere or a ground fault. All right, I'll see you when we get up there. Okay, so here's the heater compartment. 18 kilowatt. There's the nameplate. 3-phase, 480 volt. 25 ohms between each phase. Here's our control section. Got 2 fuses blown over here. Here's our linkages. They all look good. All our chain linkages. Let's get a closer look at the control section. We've got fuses blown down on the ground at the disco and fuses blown up here. Okay, so this fuse was blown, and I believe this one of them was good. The way the power comes from the disco downstairs, splices out here, it goes to these 2 breakers, and then all 3 phases go up to these fuses. The blue, that's going over to our heater. 2 of these are coming through this contactor, and that goes over to the heater as well. So one leg of the heater is always hot, the other two are switched. So it seems like the short is in that heater conductors, or the feeder going over to the duct heater. Our motor is coming down from these three. That goes to our motor. Here's the feeder for the motor, these three breakers right here. I haven't checked him yet. And then we've got some control breakers, control fuses. Here's where I was seeing the arcing before along those terminals. So yeah, let's just verify these breakers, which one is which. And I put them together. Okay, continuity check. So one line of the heater fuse is out, one line is good, and another line is blown. Let's check continuity between them. Nothing because it's open, but let's go on the load side of that contactor. Yeah, 25 ohms. 25 ohms. And then what would we do? We would do him and him. Also 25 ohms. So I'm getting 25 ohms between all of them for the heater. And then they're blown. Let's check those to earth. See if we've got a ground fault. Nothing there. Nothing there. Nothing there. Oh. Kilo ohms. But barely. Let's see, is that contactor is open. Motor's good. So it seems like the fuses for the duct heater popped. Those are motor. That'd be right here. Just checking for dead shorts in the motor windings. Not seeing any. Seems alright. So we should be able to, that's the motor is isolated. These are controls for the thermostat. That's our 120 for the door. So I should be able to replace the fuses. Yeah, power it back up. Where are these dead shorts coming from? This last guy here. Is that the primary? Yeah, so that's the primary for our control transformer. Interesting. Or no, that's a secondary. Yeah. Yeah, here's our primary, these two. Here's our secondary. So there's our 120 coming out. So our primary for the transformer is in common with A and B. B and A. And are those the ones that were blown? No, that one's good, but that one is blown. But it wouldn't have gone through there, it would have just come here. And then let's just check our 120 to ground. Nothing. Nothing. It's open. It's all good. Yeah, and then we had continuity earlier because those two legs are going through the primary. So we've got a control transformer that makes 120. We've got, here's our three-phase motor breaker. Here's our primary for the transformer. Here's our transformer secondary. This 30 amp fuse is blown and this 15 amp fuse is blown. Why are they different? Why are they different size fuses? That's not right. Okay, let's figure out the fuse sizes here. We saw the nameplate on our thing was like 22 amps. This is a 30, that's the right size. He's still good. Yeah, he's good. This 30 is no good. And what about this? 15. He's probably blown. He's the wrong size. Yeah, he's blown too. So he's undersized and wrong. Let's get the right size fuses and try it out. See what we can do with the right fuses in here. Okay, we got the fuses out. We're ready to close. Okay, close the switch. So he's going to apply power. Yeah. Good. Okay, now we can check voltage. $485, $487, $486. So the fuse is held. So there's no power to the heaters. Let's try run the blower. Power there. Power there. Whew! That blower sure made a big thud when it sucked in. Let's see, did we pop fuses doing that? So that was the blower motor turning on. Still have power there, there, there. So this time when we suck the blower on, I want to see the amperage. It is an across the line start, so it's going to be quite a bit of amps. Let's see, we can clip on here. Okay, here we go. That's working 3 amps. It's a little spooky when it turns on. The blower is good. Can you open the disconnect switch? Good. So we know the blower works. Let's make sure there's no voltage here. Good, yeah, power's out. So now we can replace the fuses for the heater. That one's good. Okay, let's double check those fuses are good before we put power on them. Good. Good. Okay, so the fuses are all good. This is our middle leg. I want to see, yeah, we can watch him. So we should see like 25 amps when he closes the switch. Okay, go ahead and close it. That's it, open it. So it sounded like those fuses popped right away. Let's see which ones did. He's good. He's good. He's good. Our control breaker primary tripped. Oh. Interesting. Let's see. Let's turn off the blower. Go ahead and close them. 25 amps. 25 amps. Fuses are holding, the blower is running, and the heater is on. Let's check our amperage. Smells like heater. Hard to tell if it's a burning wire or just it does. 23. 24. That's good. A bit of noise coming from the mower. See what amps are on. 2. 2 amps. Tell if that's a shit noise or a normal noise. That's better now. Now the problem, as it warms up, all this ice is going to start melting, dripping on everything. That's what all this is for. All right, so it turns out they keep that freezer at 0 or 1 Fahrenheit. So it was a little nipply in there, but I managed. They provided me with a nice Arctic jumpsuit and some pretty thick gloves. And most of what I was doing was just using my meter with continuity checks. So it ended up being pretty easy to do without freezing. So we got there, fuses were blown, kind of did just a basic overlook of all the wiring, see if there's any melted wires or shorts. Then also just use my meter to do continuity checks from each de-energized point, but what would normally be an energized point, to ground, to make sure there's no ground faults. Then I was able to take the continuity of each of the heating elements. It's a 3-phase 18 kilowatt heater, and they were all good. They all ohmed out to about 25 ohms, which a little bit of napkin math comes out to about 20 amps, which is right on the money for the nameplate. The nameplate said about 22. So seeing that there was no short circuits or no ground faults that I could find, we swapped out the line side fuses at the isolation disconnect down on the floor, and then with all the fuses and everything turned off up in the control panel, and then we applied fuses up in the control panel. And first I just kicked on the blower, which was loud, but that's normal for it. And then its amps looked good, it was running fine. Then we kicked on the heater, saw that the heater was good. It was sitting around 22 amps, something like that. So it was running good. The blower was making a kind of a howling noise, but I don't know if that's because I had the covers off, or if maybe there's a bearing failing or something, but I decided to just let them run that to fail. And if I can prove that there's a broken part in it, I'll recommend replacing that rather than just advising them to rebuild everything in there. We got it up and running. I came down, we tested the doors opened smooth a couple times, and then I stuck around for about 10 minutes while it defrosted and started dripping down and drying out. And I told him to call me if it happens again. So not the best case scenario where I can't find the reason for the fault, but it's a pretty decent scenario where I can at least get it running again and fix it. So at this point, we'll just wait and see. It's another one of those kind. And even though I don't know exactly what caused it to trip and blow those fuses, it's working now. And I did a bunch of checks to make sure that it's safe, it's not shorted to ground, and I didn't see any melted connections or any heat damage anywhere or overload. So that's the main thing for me. If I don't see any reason not to put something back into service just because I don't know how it went out of service, I'm gonna put it back in service and see what happens. All right, see you on the next one.